Hello everyone, I am Prashant Kumar M. Gauri. In this video, I am going to represent my paper entitled Improving Word Embedding for Sentiment Words for Sentiment Analysis. Let's start the introduction part. Sentiment analysis is an area of natural language processing. In this area, we want to identify whether the writer has provided his or her positive or negative sense about product, process, or service. Due to Web 2.0, huge amount of user generated data is available on the internet. This data has significant research value. Various organizations want to know about their product, process, or service. They want to know the feedback, whether people are talking about positive or negative about their product, process, or service. Reading out all these reviews manually is quite cumbersome task, time consuming task. So in order to handle this, sentiment analysis is done with the help of different approaches. So different techniques are involved to identify sentiment automatically with the help of computer program. First is dictionary based approach. It is the simplest approach available to identify sentiment about the product, process, or service. Generally, how many positive words are present inside the text will decide whether it is positive or not, but it requires handcrafted rule, and generating different rules and identifying sentiment is quite difficult task. So machine learning approach came into the picture. In machine learning approach, rules are identified by the machine on its own. It is learned from the pair of the samples and its exact output. Means we have to provide text, and along with that we have to provide whether it is positive or negative. Accordingly, machine will try to identify what is relationship between that text and the output. But this approach requires manual feature engineering. Which text we have to provide? Along with that text, can we concentrate on the object or verb or noun? So all these part comes into the picture. So feature engineering is quite complex task in order to get better result from the machine learning approach. In order to handle this problem, deep learning approach were introduced. In deep learning approach, we can provide multiple layers in a neural network to identify whether piece of text is positive or negative. Various deep learning models like convolutional neural network, recurrent neural network, then gated recurrent units, then long and short term memory. All these models can be used to identify whether given piece of text is positive or negative. Beauty of this approach is this approach will identify feature on its own, unlike the machine learning approach. But while using deep learning approach or machine learning approach, we cannot provide the text in its original form. We have to convert input words in a vector. Then and then only we can pass that text as an input to the models. So word embedding is a vector representation of word. Now there are certain problems with the pre-trained word embedding. Means someone has created the model, somebody has identified the corresponding vector to the word. So pre-trained word embeddings are present into the system, and we can use that. But the problem is representation for good and bad are closer to the each other, but the in sentiment analysis these embeddings should be far away from the each other. This problem arises as model is actually trained on the large general corpus. So the objective of this study is to improve the word embeddings according to their sentiment orientation. So good and bad, as shown in the figure, these are closer to the each other, and good and great is far away from each other. We want to perform certain kind of transformation in which good and great will be closer to each other, and good and bad should be away from each other according to the sentiment orientation. So in order to achieve this, we have provided the architecture. So this architecture takes three inputs: anchor input, positive input, and negative input. Anchor input is a one with reference to which positive and negative word embeddings are adjusted. So anchor input, positive input, and negative input is given to the embedding model, and embedding model consists of input layer, which will have the dimension as 1 by 300, then hidden layer 1 by 150, and uh, output layer where again we have 1 by 300 dimensions. Means input layer will have 300 neurons, hidden layer will have 150 neurons, and output layer will have 300 neurons. So the output is combined output rather is provided after the concatenation. So anchor output, positive output, negative output will be concatenated and passed to the customized loss function. So in customized triplet loss function, it is trying to identify the square distance between anchor and positive and anchor and negative. Obviously, the anchor and positive distance must be less than anchor and the negative distance, provided that anchor is a positive word. So the difference should be less than alpha. So alpha is actually the distance which will be keeping positive word embedding and negative word embedding away from each other. So after the training, we are going to generate the embedding model in a such a way that it will identify or generate the embeddings for the word according to its sentiment. So the proposed model has uh, name Senti EMB net. So after training, complete training, we can identify that positive and negative word embeddings are far away from each other, unlike the original one. So original pretend word to vec model has combined positive and negative word embeddings. So for alpha equal to 2, we got the intermixed representation. So basically every word embedding is of size 1 by 300. By using Tisne algorithm, we have brought the word embeddings from larger dimension to the fewer dimension, that is 2, for the visualization purpose. But in 3.b we can identify that positive and negative word embeddings are far away from each other. So red points are closer to each other, and blue points are far away from that red point cluster. So same is true for alpha equal to 4. So in alpha equal to 4, most of the word embeddings are intermixed with word to vec. But when it comes to the modified word embedding, it is separating the positive word embedding and negative word embedding, represented in blue color and red color respectively. So, in conclusion, we can say that pretend models need to be modified according to the sentiment orientation of the word. Modified word embedding for the sentiment word can be used for the sentiment analysis. So this modification is done with the help of senti-em binet. It contains input layer, output layer, and one hidden layer along with the triplet loss function. So this triplet loss function ensures that positive word embeddings are closer to each other, negative word embeddings are closer to each other. At the same time, these two word embeddings are far away from each other. So through result, we can say that these positive and negative word embeddings are separated from each other, and it will provide the better sentiment result. For the visualization, we have used Tisne algorithm, which have brought higher dimensional data, that is 1 by 300 dimensional data, to 1 by 2, means only two dimensions are considered for the visualization purpose. So at the end we can say that word embeddings for the sentiment analysis must consider the sentiment orientation of that word, and accordingly it should generate the word vector. So we have worked in this direction. Thank you.